Assalamualaikum and hello everyone. Experiment 3, the chemical clock reaction. The clock reaction, which is well known for its fast change in color, is frequently used in chemistry classes to find out how quickly reactions occur. In this experiment, iodine is used and termed as an iodine clock reaction. The color change occurs when iodine reacts with a starch to form a dark blue iodine or starch complex. The ability to record the time at which the blue complex appears allows the rate of reaction to be determined accurately with a stopwatch. Next, chemical oscillations are dynamic processes in which complex feedback loops cause periodic changes in reactants and intermediates. The reaction system used here demonstrates color oscillations resulting from redox reactions involving iodide ion, iodine, and hydrogen peroxide. Iodine is detected visually by starch, which forms a dark blue compound. A sequence of redox reactions is carried out by the reactant in the oscillating iodine chemical clock reaction. Objective of this experiment were to observe predict
explain the discussion part. For question 1, describe the role of hydrogen peroxide in driving the oscillations. Okay, hydrogen peroxide is the primary oxidizing agent in the reactions. It reacts with iodide and iodate ions in acidic conditions to produce iodine. This iodine is responsible for the color change to blue-black when it reacts with the starch. The continuous supply of hydrogen peroxide ensures that iodine is generated periodically, driving the feedback loops that sustain the oscillation cycle. Without hydrogen peroxide, the reaction would stop as the oxidizing power needed to regenerate the iodine is lost. For question 2, explain how ascorbic acid prevent immediate color change and affect the oscillation frequency. Okay, ascorbic acid act as a reducing agent, converting iodine back to the iodide. This prevents iodine from stabilizing in the form of blue-black starch iodine complex, allowing the system to reset for the next cycle. The amount of ascorbic acid influences how quickly iodine is reduced. If it's a higher concentration ascorbic acid, it is a faster reduction leading to shorter oscillation cycle. But if it's a lower ascorbic acid concentrations, then it is a slower reduction which prolong the cycle time. By controlling the reduction step, ascorbic acid balance the reactions and prevent it from stabilizing in the blue blood state. For question number 3, how does manganese sulfate stabilize the intermediates and why is it important for sustained oscillations? Okay, manganese sulfate acts as a catalyst that stabilize reaction intermediates by lowering the activation energy of certain steps in the reactions. It enables faster and more consistent transitions between the oxidation and reduction phases. This ensures that the reaction proceeds efficiently, preventing any bottleneck that could disrupt the oscillatory behavior. Without manganese sulfate, the reaction will slow down or become unstable, potentially stopping the oscillations altogether.
So for the third question, suggest way to adjust the experiment to change the frequency or duration of oscillation. Vary the concentration of hydrogen peroxide, which can increase or decrease the reaction rate. Change the amount of manganese sulfate to modify the catalytic efficiency. Alter the temperature of the reaction, as higher temperatures usually speed up the reaction, increasing the frequency. Adjust the pH, as oscillatory reaction are sensitive to the acidic or basic nature of the solution. So the next question, what factors could cause the reaction to stop oscillating? Depletion of reaction like hydrogen peroxide or ascorbic acid, over accumulation of reaction product that inhibit the process, changes in pH that move the system out of the oscillatory range, insufficient or excessive amount of catalyst, destabilizing the intermediate step. Lastly, relate the experiment with the real-life application. Oscillating chemical reaction like the BWK reaction are studied to understand biological rhythm such as heartbeats and circadian cycle. This reaction also have potential application in designing chemical sensor, smart materials, and understanding dynamic processes in environmental and industrial system.
The experiment was unsuccessful since the result is different from the objective because the color change only occurred during the initial phase of the experiment. The precipitate form on top of the solution also indicate that the experiment is not success. In the iodine reaction, iodine is reduced to iodide and iodide is oxidized to iodate. This electron transfer cause fluctuation in the concentration of the reacting species, which lead to the oscillating behavior and thus fulfills the second objective of the experiment.